It is prepared by the reaction of carbon with sulfur dioxide, right? And let me erase this so you can see it. There we go. And then they give us an equation. Well, we don't know if we need to do anything with that just yet, right? So I go to letter A. It says how many moles of CS2 form when 2.7 moles of carbon C react. So what should I be thinking when I go to if this is a quiz or test question in a week and a half? What should be going through your mind? Your first thing is to possibly do some test strategies. What do I mean by that? Highlight what you need to get into. We need to finish in moles of carbon disulfide, right? Would you all agree with that? What do we start in?
2.7 moles of carbon.
We start in carbon. Is there a problem there? What's the biggest problem? I have two different compounds I'm trying to convert in between, right? When you see that, what I'm going to call today is, because there's two different compounds, you're going to be doing, and I'm going to box it in, called the stoich step, that I call your stoich step. When we do our dimensional analysis, there's going to be a stoich step that gets me from one compound into a different compound, like from butter into cake. Okay? That'll make a lot more sense once we do it. So here we go. In any dimensional analysis, what do we always start with? The given. Perfect. So write down your given. 2.7 moles of carbon. Okay? How am I going to get out of moles of carbon? Well, what needs to go on the bottom of my very next step? Moles of carbon. But now here's the problem. Like, we're in moles of carbon. How am I ever going to get into carbon disulfide? Well, how did we get from cake to butter, or butter to cake? Your chemical equation, right? So we've got a chemical equation up here that we can get into moles of CS2. Well, what numbers did we use in our baking example? The what? In our baking example, how did we get numbers into a conversion factor? What's that? The coefficients. Well, what are my coefficients up here?
Nothing right now.
What do we need to do?
Balance the equation.
Balance it. Go and balance it. Yes? 5 to 2 to 1 to 4? Everybody agree with that? Okay, so there's my balance equation. Now what you need to know is that we have a coefficient ratio right now. But that also equals your molar ratio. Why is that important? Well, if we look back at the baking example, this is where these numbers came from. So what number right now, if we look at moles of carbon, what coefficient is next to carbon in your equation? 5. What number's next to carbon disulfide? Moles of carbon cancel out, moles of carbon cancel out. Now, how do you know if you're done? How do you know if you did this right? What are we looking for? Well, remember, what are we trying to get into? Moles of CS2. What are we currently in? Moles of CS2. So are we done converting? Yes, we are. So now you should go to your calculator, and it should be 2.7 times 1, everything on top, divided by everything on bottom. Now, when I do that, and this is going to be a common theme, I'm not overly concerned with your answer, because if you can use a calculator the right way, then that's not the skill. I'm more concerned with that you're setting this up right and then using correct sig figs. So how many sig figs are in 2.7? 1, 2, and this should be moles. If I just put mole there, why am I going to count it wrong this unit? There's 2 different mole counts up there, right?
So it should be mole CS2.
It has to be CS2. Because if you don't put CS2, are you talking about carbon? Are you talking about SO2 or CO? You have to put that there or it's going to be wrong. And there's your answer. This step right here is what I was talking about with this box. That is your stoich step. 1 second. That is the brand new thing, the only new thing that I'm truly introducing for this lesson. This is the step that gets you from one compound into a completely different compound via the balanced chemical reaction. Y'all that's the lesson, what I just said. That stoich step that I boxed in, getting from one compound into the next compound using your balanced chemical equation.
Where's the exception?
There isn't.
It's a lie.
Now, there's more to it. We'll talk about it in a second, but there's no exception. Okay? So if we go down to B, go to B. I'll do another one with you, and then you're going to do C and D by yourself. What? With what? No, so listen. So I'm going to be boxing in the stoich step each time. The stoich step is getting from one compound into the different compound using your balanced equation. Right? So each time, and if you want to do that, by all means do that. And listen, before you got work point just for trying some type of dimensional analysis. On this unit, if I don't see that stoich step, it doesn't have to be boxed in, but I'm going to be looking for it. If you don't have that step in there, you're not getting a work point. Y'all follow that? You can't just write down 2 times 2 equals 4 and expect to get work points anymore. Right? You need to have that in there. Now, some of you will switch those numbers up because you still get confused sometimes on what goes where. That's a different story than just writing down numbers just to get a work point. Okay? So, let's go to B. Right? If we go to B, we use our testing strategies. I'm starting in moles of carbon, but I need to get to moles of SO2. That should be a big red flag because I'm starting in one compound. I need to end in a completely different compound. Right? So I write down my given. 5.44 moles of SO2. How am I going to get out of moles of SO2? Put it on the bottom. Now, is there a quick way to get from moles of SO2 into moles of carbon? Is that a conversion factor that I know of? Yes, it is. From where? From my chemical equation, right? How many moles of SO2 do I have? Remember how we said that coefficient is also a mole count?
Oh, you did that. Did we just look at the reactive side?
No, it can be any of them. I'm going to talk about that here in a second. What about moles of carbon? 5. Cross out moles of SO2. I'm currently in moles of carbon. What do I want to be in? Moles of carbon. So do I need to do anything else? I'm done. Put into your calculator. This should be 5.44 times 5. That answer gets divided by 2. And then I should have 3 sig figs moles of carbon is my answer. Now, a little side note, especially when you do quizzes or practice in Chem Quiz. You're all ready? Because many of you missed questions on the chem quiz because of sig fig issues. Are you ready? If I have this as my calculated answer, 46,500, and I needed 3 sig figs, think about what you would write down. Because a lot of not a lot, but a good handful of students wrote down 465 and circled it. What's wrong with that?
Not the same number.
It's not the same value at all. Sig figs, we do some rounding, and so when you say the same value, it's not always the same value, right? But it's pretty close. If I owe you $46,500 and I give you $460, is that going to satisfy what I owe you? No way. That's
Not if
way
they're
off.
actually wanting what.
That's not even close, right? So what am I saying? Are those zeros significant? They're not significant. So how many sig figs do I have in a calculated answer of 46,500? I still have 3, so that is my answer if I needed 3 sig figs.
I thought you were asking if they were exclusion.
They're important, but not as significant, right? The other issue is, let's say I get a calculated answer. Hopefully you all are paying attention to this because this is just a sig fig review. If I get 4.25 times 10 to the 24th as a calculator, like I didn't put my calculator in scientific notation. It just popped this answer up when I did my math. And then I have people saying, okay, so 3 sig figs, 4.25, and circle it.
What's the times 10 to the 24?
And they're like, well, this doesn't matter because it doesn't matter for whatever reason. Do those zeros matter? Yes.
They don't count as sig figs. They matter.
So all of these zeros are not significant. They're all zeros.
The 24 zeros.
Well, 23 zeros. Well, they're almost all zeros. But they're all insignificant zeros. And it doesn't matter if it's to the negative 24th. Those zeros are all insignificant. Can you all kind of follow that? Because some of you put in these answers into Chem Quiz, and that's why you got like 1 out of 5 or 0 out of 5 because you just had sig fig issues, right? The last one that I need to go over is you get an answer of 0.00465 and you need 3 sig figs, and you write down 0.465. Or you write down 0.004 or 0.005. Why are all of those wrong? Matthias, why are all those wrong? What about the zeros? They are insignificant. Which means for 3 sig figs, that's your answer. These are not significant zeros. 1, 2, 3. So once again, if you're missing things on Chem Quiz, those are things that you should be looking for, is if you're just missing significant digit issues. Why do I do that? Because I don't always give you answers in my examples. But what I want you to know is when I give you 2 dashes or 3 dashes, that doesn't mean your answer's 3 digits. Why is that? How many digits are in 46,500? 5. How many are significant? 1, 2, 3. Right? So those dashes only are representing significant digits, not necessarily all of the digits. Do you understand that? I think maybe that was a little miscommunication when I started doing that at the beginning of the year. All right? So back to what we're supposed to do. Go ahead and do C and D if you have not already. I'm going to do the work up here so you can check. But don't look up here until either you get stuck or you're ready to check your answer if you've already done it. see work.
So what I did.
No, I just need to see it.
Oh, well, it was mental math.
That's fine. But on your, you're going to get, on your quiz and test, you already know that you get work points, right?
Oh, I told you I said I like C instead of C.
Look, I got it up there. You can see it? Now, once again, guys, I'm not overly concerned with your calculator because if you got exactly what I have up here, just sometimes we get fat fingers and we push the wrong button and we do some crazy things on the calculator. I can't fix that. I can't, those are just little small errors that we do sometimes, right? This stuff is what I'm really looking for. You understand that? So you should get the right answer if you put this into your calculator the right way, all right? Now, when we look at this, what is the common thing through all of these questions so far? What's that? They're all one step because what do we always start in? What unit do we always start in? What do we always end in? Moles, right? That's why it's just one step. Now, I told you that this was the new step for today, your stoic step, but yet there's more. What could we do to make it more? How would I make this a two-step stoichiometry question? So I could end not in moles, but in grams or in volume or particle amount, right? Because then I could go from this mole count into something else. And that's what we're about to do. So it's not hard, it's just something I have to bring your attention to because what I'm about to show you is going to be the biggest mistake that most of you make while learning and practicing this stoichiometry. Okay? So I've got to clear this out and go to the back of your packet, of your notes packet. Go to the back of your notes packet. So this set of questions is going to be the most test-like that we do today because it's all words. There's no guidance of what to do. There's nothing there. So this is how you're really going to see it on your quiz and test. The only thing that makes it not quiz or test-like is that this is the stoichiometry unit, and we're going to be solely right here, right? And we'll talk about this in a second, about what to do there, right? So let's read this question. How many moles of iodine? That should be something I highlight because that means moles of iodine is what? My goal. That's what I want to get into. That's important. Some of you need to be doing more test strategies to make sure you're giving, using the right numbers. React with 20 grams of ammonium sulfide. Why is that important? That's what? That's part of the equation, but that's my given, right? I should also notice that I need to end in iodine, but I start in ammonium sulfide. That should be my biggest indicator that I need to have what in my dimensional analysis? What have I been calling it? My stoic step, right? So that's why I drew that box. When I draw that box, that means, okay, I need a stoic step in there somewhere because I'm changing compounds. Y'all get that? What do I need first to change compounds? What do I need first? A chemical equation. Where's my chemical equation? You have to make it. So what do you think you should do right now? Come up with your chemical equation. Go ahead and do that from this word problem. Now, I'm going to do it up here, but once again, if you're just copying straight from up here, we might need to come in and talk about how to write equations. That's good. If you truly didn't, that's great. You need to be recognizing that. But if you did, we'll come back to that, right? So now that we have our balanced equation, we can move forward with our stoichiometry and trying to get to that stoic step, right? But there's going to be one little hiccup, maybe a little hurdle that we need to get over first, right? So what is my given? 20.00 grams of ammonium sulfide, right? Well, how am I going to get out of ammonium sulfide? Get it on the bottom. Grams of ammonium sulfide. This is where I see most of those. Remember that mistake I was talking about? So if you look at your past examples, look at those 4 examples that we did to start the class. What do all 4 of those stoic steps have in common? If you're not looking at it, you can't answer the question even in your head. So you need to look at the first 4 examples. The things that I boxed in, hopefully you boxed in too. What do all 4 of those have in common? They're all in moles, right? Everything that we're talking about is in moles because it came from your chemical equation. Does any of them have grams in it? So what I'm telling you right now, and you might want to write down somewhere if you think you need to, is that your stoic step has to always be from a mole of something into a mole of something else. You cannot have grams of something into grams of something else. So I'm going to show you the wrong thing right now. So don't copy down what I'm about to show you. So a lot of people want to say, okay, we have grams of NH4. And because I want to get into moles of iodine, we're going to go straight into moles of iodine. Is that a true conversion? That is the wrong conversion. Now, the harder part is when you have to, this one ends in moles of iodine, there's going to be some questions that want you to end in grams of iodine. And so people are like, okay, we can get from moles to moles by your stoic step. Can we get from grams to grams? Guys, get the cell phones put away. If they're in your laps, if they're on your desks, they need to be put away. All right? So if we cannot go from grams of something into grams of something else, we have to use the stoic step. And in the stoic step, it's only moles of something into moles of something else, which means I've got to turn NH4S into what? Moles. I need to get this into moles of NH4. How am I going to do that? This was last unit, guys. How am I going to get from grams of something into moles of the same thing? The molar mass, right? So right now, yes, it's up on the board. That's the top part of the board. Y'all see that? That was last unit. So go ahead, where that empty box is, you need to find the molar mass of NH42S. What's that? Because to get to our stoic step, which you know why we need a stoic step, right? To get to our stoic step, we have to have moles. The stoic step is the only way that we can convert from one thing to another thing is through moles, because that's what's in our chemical formula. And I believe this molar mass is 1.44? If you don't believe me, go ahead and do it. But it's 68.144. Now, here's where we need to keep moving forward. I'm out of grams of NH42S, grams of NH24S. I cross those out. I'm currently in what unit? Moles of what?
So for NH4S, I got 50.
No.
2S. There should be a 2 here. right? So we're in moles of that, but I need moles of iodine. So I know I at least need to take this one more step. Well, if I need to get out of that, that has to come here on the bottom so I can get out of it. And then from moles of this, is there a conversion into moles of iodine? But I have to have what first? The balanced equation to use those coefficients, right? Well, good thing I've already done that. Because if I didn't, listen, let's say you just went to number 3 and you just start doing this, you should stop at this step and say, oh, I need coefficients. Now I need to go balance an equation somewhere. And that wouldn't be completely out of order, but you should notice that you need to stop right there to get that balanced equation. But now that we already have it, what coefficient goes with moles of NH4S?
1.
What about iodine?
1.
And there you go. Those cross out. I'm left with moles of iodine. Am I done converting?
Yes.
Because that's what the question's asking for. The question asks for moles of iodine. I'm currently in moles of iodine. I'm done converting. Now I go to my calculator. Right? And I need how many sig figs?
1.
How many sig figs?
4.
1, 2, 3, 4 moles of iodine. There's my answer. Once again, remember, that's 4 significant digits. That doesn't mean there's not more zeros somewhere, but those zeros won't be significant. Now, the new part to this question was we started in a gram, in a mass. Once again, the biggest mistake I saw from my classes when they had time to work was this right here. They were trying to take grams of something into moles or grams of something else. That's not a true conversion factor. Our conversion factors from one thing into something else only come from your balanced equation. That's your stoich step. So if I had to box that in, there's your stoich step. That is the new thing. Now, the only thing that makes this a little bit longer to do is, y'all listen, because we're about to do one like this, is if I start in a mass and I have to end in a mass of something else, right? Because I could take this. What if the question said grams of iodine? Well, I'm currently in moles of iodine. What would I have to do? One more step, moles of iodine, grams of iodine on top. You see what I'm saying? Those are the longest ones. The mass is even longer than the gas and the particles because in gas and particles, what does those conversion factors give you? The number right away, 22.4 and 6 and Avogadro's number. Okay, you don't have to figure out the molar mass like you do here. Right? Now, one thing to be a little bit cautious of, and I know you get tired of me saying this almost every single day. What happens, because if this were a test question, I know where most of your mistakes would stem from, would originate from. You ready? That too, an iodine, and that too, an ammonium sulfide. Because some people would not cross that -2 charge from sulfur down in this iodide compound. So watch what happens. Let's say you don't put that 2 there. Right? That means you don't balance this correctly. Which means your stoich step is off. If you don't put that 2 there, your molar mass is off here. Just from one little subscript number. Because you didn't write the formula correctly. You need to be slowing down when you write these formulas until you get super comfortable. It's diatomic. Brinkle, bring, B-R-I-N. That's where it comes from. When it's by itself. When they've got to be... Guys, it'll say like gas in there. It's not up here. This doesn't say gas, but most of the time it does say gas. But you do need to memorize those 7. All right? The last one that we're doing, and then you're going to have time to work quite a bit on your own. Go to your homework packet, or your homework page. and it's number 2. Actually, let's do number 1. Okay, let's do number 1. Predict the products and write the balanced chemical equation. So, how many grams of sulfur is burned? That's the word prop. Sulfur is burned. Well, sulfur is sulfur diatomic.
What is it?
Are you all on it?
We don't have it.
Maybe I crossed this one out.
Our first one is potassium reacts with chlorine gas.
Oh, good. That's what I was looking for. Where are you? Come on. There it is. Maybe. Let's do, because I know you for a fact you have this one. Do number 2. I don't know why that's not on mine. Let's go to number 2, the copper one.
We don't have it like that.
Ours is not 15.
No, go back down. You were on the back. That's why.
There we go. This one. You're the front page? Number 1. That's one I want to get to. All right. So, grams. Good. So, predict the products, write the balance equation. So, you have when potassium reacts with chlorine gas, potassium chloride is produced. So, question, part A is write and balance the equation. So, it should be potassium reacts with chlorine gas to produce potassium. Now, for some reason, guys, a little side note, and I'm sure somebody out there did it. Somebody put a lot of people have been putting a 2 there. K2Cl. Now, my theories are that they're just blindly bringing that over, which is completely wrong. Or they're thinking that chlorine has a +2 charge, and they're crossing it down. Both of those are the wrong way of thinking. Okay? It should be KCl. +1 for K, -1 for chlorine. Now you need to balance. Everybody good with that? Right? Then letter B. How many grams of product? Well, what can I cross product out with? That's my product. KCl is my product. Is made from 2.5 grams of potassium and excess chlorine. Now, y'all saw this on your baking example, right? And we talked about it for a second. This excess means, and you're going to see it quite often, this excess just means that we have enough of everything else to react with whatever the question's asking about for it to work, right? Because on Friday, that's not going to be the case. We have to figure out what's in excess and what's limiting that reaction from moving forward. We'll talk a lot more about that on Friday. But that excess doesn't mean a lot to you today, Tuesday. All right? So let's start with our given. 2.50 grams of potassium, and I need to get out of grams of potassium. How am I going to get out of grams? First off, do I start and end in the exact same compound? I want to end in KCl, but I start in what? Potassium. Is that the same thing?
No.
Which means I need a stoich step somewhere, which is why I have a balanced equation up here. So can I go, and this is the biggest mistake I've seen so far, can I go from grams of potassium into grams of KCl? You cannot. Once again, that is the biggest mistake that I've seen. Don't do that. But I have to have grams of potassium on the bottom. So it crosses out. So that's good. But so what can I turn grams of potassium into? Moles. So 1 mole of potassium. Well, what number goes on the bottom?
39.1.
The molar mass of potassium, which is 39 point what?
10.
Oops. Yes? So now I'm in moles of potassium, but that's not where I want to be. So I know I need to get out of it for sure. But I can turn 1 mole of potassium into what? I can turn it into KCl. Sorry, moles of KCl.
So once it's in moles, that's what you change it to.
Yes. So how many moles of potassium are needed to react with how many moles of KCl? 2 and 2. Those numbers came from the coefficient in your balanced equation. So now I'm out of moles of K, and I'm currently in moles of KCl. Is that where I want to be? Can I stop right now?
Wait, no.
Can I stop? No, because I want grams of my product. I want a mass of my KCl. So what do I have to do? One more step, moles of potassium into grams of potassium. How do I do that? Oh, I'm sorry, the KCl, yes. KCl, grams of KCl. How do I do that? The molar mass, right? So 1 mole of KCl is equal to the molar mass of KCl, which is what? 74.55. So moles of KCl cross out, and I'm left with grams of KCl. Everything's crossed out. All of my units are crossed out besides what I want to end in. And then when I get my answer, I should have 3 sig figs. 1, 2, 3. Grams KCl is my answer. And again, for your work point, I will be looking specifically for that step right there. That's boxed in. That is your stoic step. Everything before this is old. That's what you just tested over. Everything after this is what you just tested over. This boxed in step is the new thing for today. That is your stoic step. How to get from one compound to a completely different compound. They just have to be in the same chemical equation.